So our last speaker of the day, Joe Kazuhiro, and a long title, beautiful title there, and I'll let you introduce yourself. Thank you so much.
Okay, so first, thanks Alex for the team to giving me such opportunity. I'm Joe from the Department of Acoustic Design, Kyushu University in Japan. And today I'm going to talk about my work, Fragmented Music, Procedures, Behaviors, and the Culture from a record without pre-acoustic information, which I continue around more than 10 years. So first, quote, so I have suggested to change the gramophone from a reproductive instruments to a productive one, so that on a record without pre-acoustic information, the acoustic information, the acoustic phenomenon itself originates by engraving the necessary edged grooves. So in 1923, over a century ago, Bauhaus-Meister Lazaro Moholy-Nagy proposed the above idea. At the time, it was just a provocation. However, nearly a century later, we have realized the idea with the help of the mature computational technologies under the name of the record without pre-acoustic information. Instead of using the vibration of the original sound, we visually draw a pattern of grooves with a conventional vector graphics application, namely Inkscape or Adobe Illustrator. So in the case of the Illustrator, the amplitude of the waveform is defined by the size of the zigzag, while its frequency is determined by the number of the ridges per segment according to the following algorithm. So here, F stands frequency, Z stands number of the zigzag, and A stands angle of arcs from 0 to 360 degrees, and RPM stands for a revolution per minute, 30.3, 45, or 78. For Inkscape, we developed an extension to enable this zigzag effect. With the extension, you could make an arbitrary frequency with the number of segments according to the same algorithm. Here, demo. So actually, I'm gonna have the workshop tomorrow with this technique, and then I'm gonna show you how it works. Oh, not Keynote, sorry. Open Inkscape, create new document. Okay, oops. Weird some bug. What's happened? I don't need that song. Let's see. Okay, here. So now basically draw a circle and set the size into 150 and 150 here, and several techniques, but apply zigzag for each, maybe 44 here, and to here. Then we're gonna have the shape of the zigzag, and then we need to connect. line. And create small circle to make the whole turntable. And align in center. Almost done. Then export. So this is a cutting plotter. So it's almost like printer, so that you could cut any vector data. And then actually, instead of cutting, I just etched the surface of the thick paper right now with the data. So here we are. And scissor. A4 is too big for the turntable. Then maybe, but anyway, you could get the idea, I hope. Thanks. And back to the slide. Let's see. Oops, not that. Yes. And here. Okay, and unlike standard cutting machines, we use cutting plotter or laser cutter to engrave grooves. And these grooves are cut horizontally into diverse material, acrylic, wood, paper, metal, and porcelain in a non-scalable artisanal manner, instead of being produced in a scalable mass production process of vinyl using a stamper. So that results can be played on ordinary turntables like this. And historical references. So in early 1960s, a Czech artist, Milan Nizak, started to create music from defective, worn, damaged, or broken LPs. He began stick tape on top of records, painting over them, burning them, cutting them up, and gluing different parts of records back together to achieve the widest possible variety of sounds in the name of the broken music. And this is one of the references for my work. And here, Fragmented Music. This is a work which I actually, over 10 years ago, that I made it. And it's a work of record player acoustic information, which got influence from the Nizak's block music in part. And instead of directly damage existing vinyl records, we engrave different patterns of groove in the form of arcs of various angles onto different colored acrylic plates with a laser cutter. And here, each color corresponds to a specific number of the zigzags it means the frequencies. And the ranging approximately from 60 to 120 Hertz at 33 RPM. And here, gold segments represent silence with its smooth curved lines, and a silver outer ring prevents centrifugal scattering. So the group endpoints and actually the endpoints of each group of the arcs are centered for connectivity. And to prevent needle skipping between arcs, we changed the focus of the laser cutter, the blood to wide the width of the groove. Next demo, and we're gonna have actually the next tomorrow evening, we're gonna have a performance as well. And here is, I already set my work out here, and this is the arcs. Okay, thanks. So it sounds like that. And if you change the sequence of the arcs, it could produce different beats base. And here I put the records on this work with the LKO. Here's the turntables in Tokyo. And you could check the sound with the QR code if you want. Actually, we have the two sets of the work, and one can physically rearrange the series of the arcs into looping sequences to spin one after another within a standard analog DJ setup like this. And discussions. So from the point of the algorithmic patterns, the theme of the conference, as described at the beginning, the foundation of the work is a simple algorithm that produces arbitrary frequencies through a zigzag pattern resembling almost like sine wave, determined by the angle of the arcs and the RPM of the turntables. In this system, the segment represents either a frequency or a silence, and the entire series of arcs functions as a loop. As the turntable continues to spin, manipulating the order of the colored segments generate different sequences akin to a rhythmic pattern. And, oh, sorry. And even without drawing actual groove patterns, skipping the needle to the edge of the arcs causes rich variation of the sonic emptiness that resonates with a work such as Maria Shevitz, and the deviation from the sequence of grooves unfold into shifting rhythmic textures arising from the gaps between arcs at different angles. It sounds like this. Okay, so the next. So, and the next discussion in this, yes. So from the point of the hybrid musical instruments, in our talk about the future of the music and the recorded music, Japanese composer Masahiro Miwa described our project as follows. Quote, in my view, it's like hacking recording media to demonstrate sound synthesis. Typically, sound synthesis is done with electronic circuits or similar means, but in this sense, it results in being engraved on the medium records. So it's intervening directly with the recording media and demonstrates the process. In this context, Our work, including fragmented music, can be considered as a kind of the sound synthesis device akin to analog synthesizer. And on the other hand, Japanese sound studies scholar Katsushi Nakagawa observed our work as like this, quote, "I'd like to draw attention to the fact that these records produce sounds that seems to be nothing but electronic tones. When played back on a record player, these records engraved with mechanical and physical regularity, but devoid of any electronic processing of the sound, start emitting thick, rhythmic, electronic-like bass tones. It's a curious sight of our auditory experience. We can't help but feel a strange sensation as if we have been tricked." Here, Nakagawa highlights that audiences are not listening to an original sound, but rather perceiving an acoustic production system. What they perceive is not a faithful reproduction of an original sound, like the standard analog record, but an acoustic artifact shaped by mechanical inscription. So given these and fragmented music ability to generate alternative rhythmic relationship by reconfiguring patterns, the work may be better described as a hybrid musical instruments, combining the non-electronic synthesizer and the step sequencer, disguised as a record on a turntable. And last part. So, a French philosopher, Jacques Attali, noted as, quote, "In music, the instruments often predates the expression it authorizes, which explains why a new invention has the nature of noise," quote. If it's accurate, the series of grooves in our work, fragmented music, may represent an alternative history or the future of music, one which recording and playback technologies are repurposed to create rather than reproduce sound by engraving groove patterns originally drawn as images in conventional applications, namely the Illustrator or Inkscape, with a simple algorithm onto the surface of acrylic fragments. Thank you.
Thank you very much. And now we have some time for questions from the room, if anyone would like to kick us off with a question. Yeah. Thank you.
Hi, thank you very much for this nice presentation. I enjoyed it a lot. Just one question. Have you also thought about visualizations towards your music? Like combine it with a visual element?
Visual elements, but sometimes I performed with the camera on here to, visualize the sequence. So that's one of the way. And but you mean a more computational way or like that?
Yeah, or like an animation which is like maybe also taking up this theme of the brokenness, or
maybe we could. But as a visual, if you come here, the visual is also represent the sequence of sound, so that it should be kind of the good way to not to code the entire visual segments, but to just represent the visual and the sound simultaneously as a physical object. That is the kind of things which I'd like to do. Yeah.
Thank you very much.
I actually had a question for you.
Yeah.
In your paper, I was reading you were working with lots of different materials, so acrylic, metal, porcelain, paper, and I was just wondering which was your favorite or most surprising material in terms of sonic properties.
Actually, I forget to show you, but we have two different materials with a same data, and maybe I could perform. So first one is paper. Sorry. Okay, so this is the French old folk song, the Okra de Lune, the name of the song. And then I use the same data for paper, wood, acrylic, metal, and porcelain. Shards. So here, the data, the computational data itself is same, but you could listen to very different sounds from the different material. And actually, the ceramic, actually, my brother, the potter, and it's collaborative work, brother's collaborative work, and the most of the oldest recording media is the kind of the Edison's phonograph, and it's around 150 years history. But we couldn't, play back the original phonograph already. But ceramics, we have the more than 10,000 of the history to keep the ceramics. So it means, maybe I could say, I invented the most reliable audio medium after the 150 years ago of the invention of the Edison. So that's one of my favorite.
Nice,
Thanks.
wow. Thank you. That was the best answer to a question I've ever had. And I think we have time for another question in the room.
Hi, I really like how you made it modular so you can rearrange the sections.
Mm-hmm.
And I was curious, what is the decision about the distance from the center, how you decide how far the line should be, and why not encode other lines so you can pick between? What is the thinking behind that? And also, do you have like a special needle so it doesn't pop when it goes between bridges if they don't quite line up? Is that an issue? Or?
Right. The second question is easy to answer. I use the standard needle, but the good one, the Ortofon Concord, I use to prevent the skipping. But you could use in other player, not only the techniques, but also the other standard player could produce a sound with the record. And then good question on the position and the number of the lines, because it takes lots of time actually to make that piece, because we need to defocus the laser cutter, and each time I failed, and then at last we made it, and then so the answer is to make the different lines and to change the position. It's too much of the work.
Okay, I see.
Yeah.
And when you talk about defocusing, is that so you can get the cone?
No. Change the focus then to make the width of the groove wider.
Right,
because if you have the
yeah, it's too thin.
Yeah, too thin.
Okay.
Yeah.
Okay.
That's
Thank
trick.
you.
And I tried to reproduce the work, but I failed. Thanks.
That's very interesting.
One more question.
Yeah, please.
Thank you. It's super interesting, like the material speaking in this case.
Mm-hmm.
And just on the previous question,
Right.
Have you tried doing the work with a CNC machine? Because like the laser has some level of sputtering on the surface of the blasted material gets. And I think that the blasted material also provides part of the texture of the sound that you're actually reading with the. But have you ever tried to perform this operation with a CNC machine, like a carving machine? I know that there are very high precision ones. So.
Yes. I once tried to the CNC machine to cut the surface of the wood, and it worked. But I never tried a very precious one, and I'm not sure that if it really works or not. But yeah, if you could, and actually, the algorithm and the way to make the record is not so complicated.
Yeah.
So please make it by yourself.
Okay. Thank you.
Thanks.
Great. Thank you very much. Let's have a round of applause for Joe.